first session of the day of free tracks. And we have here with me David Delabassee. Hey, David, how's it going?
Good, good. Hi, Roberto.
Hi. Thank you so much for joining. So you've been here. This is our first session, or this is our first edition, I mean. And you've been on every edition of JNation, right?
Yes, exactly.
And now you're actually doing it online. So you've been to Portugal a couple of times, and you're going to be your third time, but now you're doing it online. Yeah. So hopefully you can come here next year and have some fun, right?
Yep.
Yeah. So David's going to talk to us about Java and the 40 versions, right? The summer 2020 edition. And I'm really looking forward to see this session. So thank you so much for bringing this to us. So you know the drill. So for the people that are watching us online, so we already shared the Slack channel link. Feel free to post any questions that I'll be happy to relay them back to David if we have some time to QA in the end. Is that okay for you, David?
Perfect.
Okay, wonderful. So without further delay, so feel free to start.
Okay, thank you, Roberto. So first of all, thanks for having me today. It's really a great pleasure to be back again, even if it's remotely at GNation. So my name is David Delabassee. I work at Oracle in the Java platform group. So that is the group within Oracle that is responsible for Java, the platform. Sorry. Okay, so well, despite everything that is going on in the world today, well, I'm really happy to be here. So today we're going to discuss Java and the 14 version. So you might know that the Java cadence has been accelerated. Every 6 months we have a new feature release. So that means that in 2020, we will get 2 releases. We already have one, which is JDK 14, and we'll get another one in September, which will be JDK 15. So my plan today is basically to give you an overview of what Java will bring you in 2020. So that is in Java 15, that is already available today, but also what is coming in the 3 months from now in 15. So this is how you can tell that I'm working at Oracle. So the thing that is important to keep in mind is that JDK 14 is released, JDK 15 will be released. So until it's released, things might still change. That's something to keep in mind. Okay, this year is a very important year for Java, given that we are celebrating the 25th year of Java. So that basically means that since 25 years, Java has been evolving based on 2 core principles. The first one, developer productivity. So it has to be simple to write Java application. And the second core principle of the platform is application performance. So since many years, we are doing improvements within the platform to make sure that your code runs efficiently. Now, this has been done in the face of constantly evolving paradigm, such as programming paradigm. For example, in the last 10 years, we can clearly see trends that Java is evolving slightly toward more functional approach. It doesn't switch to functional programming, but it had up some of the nice concepts from functional programming. Application styles has also greatly changed in the last 25 years. So 20 years ago, for example, you were writing monolith application. Obviously, those days, it's all about microservices. And Java is evolving to cope with those application styles changes. Deployment styles has also changed quite dramatically. In the early days, we were deploying in our own data center on a large servers. Those days, we were basically deploying our code within containers in the cloud. Again, Java is evolving to cope with those changes as well. And finally, Java is also evolving to cope with the hardware evolutions. So more and more we have in our machine, we have more CPU, we have more cache at different levels and so on. So that's also something that Java has to cope with. So the first few minutes of my presentation is basically to give you an overview of where we are in terms of the Java release, and then we'll really drill down within JDK 14 and 15. So this is Java 9, which was released in 2017. It has been delayed 2 times, and I'm not gonna spend any details on that. But what we can see from this slide is that there were a lot of features in that release, and that was an issue because developers were given a large platform with many features, and it was very hard to basically learn and master those features. That's why we have changed the way we evolve the platform. So from now, since Java 9, basically every 6 months, there's a new Java release, and it's a fixed cadence. So right now we are at 14, which was released in March, and the next one will be 15, which will be released in September, and so on and so on. So that's a given. Those releases are supported for at least 6 months. So that basically means that right now the current release is 14. It will be released at least until 15 comes out. Now, we also acknowledge that some users are not able to switch every 6 months to a new feature release, even though the scope of those feature releases is smaller. So it's easier to move from, let's say, 13 to 14 than it was to move from 8 to 9, for example. But we acknowledge that some users, typically enterprise, are not able to do that. So that's why we take some feature release and we mark them as a long-term support release. So 11 is the current long-term support release, and the next one will be 17. So every 3 years, we take a feature release and we mark it as a long-term support release. That basically means that if you want to get support for that long-term release, well, you need to buy that support. That's a commercial support. But still, Oracle offers choice. So either you use the Oracle OpenJDK builds, which are free. Every 6 months you have a new release, or if you want to stick to a long-term, if you want to use a long-term support release, then you need to have some kind of commercial support with Oracle. Now, I'm not going to spend some time on this. The only thing that I want to say is that whenever you buy support for Java, it's a good idea to look at two things. First, the price, how much it costs. And well, the price for Oracle support is public, so you can have a look at that. And honestly, it's not expensive. It's quite cheap. The second thing that you need to look at when you're looking for a company that can support your Java stack is basically look at who is the most capable of supporting that stack. And this slide shows the fix that were fixed in JDK 14 by the different organizations. And we can clearly see from that slide that Oracle is the largest company that has fixed and contributed to JDK. Well, in 14, but that was also true for the release before. So the key takeaway here is that Java is still free. Nothing has changed on that front. Now, let's talk about some of the mechanics that we put in place to basically enable faster innovation within platforms. So first, we have the JEPs, the JDK Enhancement Proposal, which are basically a lightweight mechanism to specify a new JDK features. That's something that we are using across the board for adding new features in the platform. We have the new predictable release cadence. So every 6 months, we know that we have a new feature release. What gets in really depends. If a given feature is not ready to get into the platform, it's not really an issue because that just means that that feature will have to wait another 6 months for the next feature release. Something that we didn't have in the past. So that's why in the past we had to delay Java release because a given feature that was set to be added into a specific version was not ready. So we basically had to delay the whole train. We don't have that issue anymore. Something else that we put in place is a different type of feedback loops that basically give us the ability to give to developers non-final features that will be added into the platform. The idea is that we want to give the developers the ability to test early on some features before they are made final into the platform. So that gives us the ability to developers to provide feedbacks. So does that feature work as expected, for example? And on our side, we can make some final adjustments if we have some actionable feedbacks. So there are multi-type of feedback mechanism. Preview feature is the one that we are using the most. We also have experimental features. So preview feature is used, for example, for language features. Experimental feature is something that is used for hotspot specific features. And then we have incubator modules. And also we also have early access JDK builds. Whenever a feature is not ready, whenever a feature is not is in development, feedback is still important. So for example, we'll see that for Loom, Project Loom, for example, we have early access JDK builds that gives developers the ability to test with early prototype of Loom in this example. Something else that we put in we put in place some time ago is Project SCARA. So the goal of Project SCARA was basically to investigate alternatives to the source code management that OpenJDK has been using for years, and that is Mercurial. So SCARA had to go look at alternative, so an alternative solution instead of Mercurial, and then also look at a potential hosting provider for that solution. It has been decided on one hand to use Git as the new SCM for OpenJDK, and the provider would be GitHub. Having said that, one of the key aspects of SCARA is making sure that we are not locked to any provider. So if for whatever reason over time we need to switch from GitHub to, let's say, for example, GitLab, that's something that is possible. So shortly, around GDK, the ends of GDK 15, so in a few months from now, all the OpenJDK development will be done on GitHub. So github.com/OpenJDK is the organization. Right now, there are already a few projects that are using that organization. So the development, for example, of Loom and Panama foreign is done there. But the core of the GDK will also move. Well, it's already there, but in a read-only mode. But the core of the GDK will move in a few months from now, around the end of GDK 15, which should be around end August, maybe early 16. We'll see. But anyway, that's something that will happen shortly. So basically, all those mechanisms help us to innovate faster into the platform. We can more easily add new features. We can give them those features early access more easily. We can cope with the feedback that we are receiving, and so on and so on. So we are able to deliver faster. Now, let's talk about the pipeline. So this is Java 10. 12 JEPs were added in Java 10. In red, those are the JEPs that are not done by oracles. So the garbage collector interface was done by Red Hat, I believe, and the other one was also done by Red Hat, heap allocation on alternative memory device. So that's the content of 10. 6 months later, we had Java 11. More content in 11, but again, any feature release is not driven by its content. It's driven by the dates, right? 12, the content of 12 was a little bit less than in 11. And in 13, we haven't had less. That's not an issue because 15, the current feature release, is basically compatible with that. So this is the content of the JEPs that are added in 15. In 14, sorry. Now, it's something important to mention. The JEPs process is also used to deprecate and remove older features. So if you look towards the bottom of the slide, for example, you can see that in 14, we're deprecating the parallel scavenge and the serial old GC combination. We are also removing the PAC 2000 tools and the PAC 2000 API. So evolving the platform is about adding new features, but it is also about deprecating and removing older features. So that's what we're going to discuss today. So GDK 14 was released in March. So that's something that you can use today. It's available, right? Now, in terms of 15, the thing that we know is that 15 will be released in September, and the ramp down phase 1, that's basically feature freeze, is happening in 1 week from now. So that gives us the ability to discuss what will be in 15. Again, keep in mind that things might be dropped at the very last minute, but anyway, we are on a solid ground to discuss 15 today. So Java is still free, delivering faster, richest features pipeline ever. That's a given. In parallel, we are working on multiple ambitious projects that with the goal of revamping a given area of the platform. So, for example, ZGC is about creating a new scalable low latency garbage collector. Loom is about completely revamping the way we program concurrent application. Valhalla is basically about rebooting the way we deal with data into memory. So those ambitious projects takes time, and they are delivered gradually into the platform. The first one that is nearly done is ZGC. So ZGC is a scalable low latency GC. When we say low latency, that basically means that the aim is to have the post time stay below 10 milliseconds. But most of the time we observe post times around 2 milliseconds, which is very low. It's scalable, so the post time do not increase with the heap or live set size. And ZGC is able to handle small heaps, like 8 megabyte heaps, to multi-terabyte heaps. And again, the post time shouldn't increase. It's a concurrent GC, so meaning that all the heavy lifting work of the GC is done while your Java application threads are running. And basically all the GC operation except the thread stack scanning is done while your code are running. So ZGC only need to do a post to scan the thread stacks. So that greatly limits the impact the GC is having on your application response time. How to use ZGC? Well, right now in 14, so ZGC is still an experimental feature. So you first need to unlock ZGC with these flags, unlock experimental VM option, and then you specifically need to enable ZGC with the use ZGC. And then you need to tune ZGC. And basically tuning ZGC is as easy as setting the heap size. That was also one of the design goals of ZGC. Basically tuning, the default behavior should be very efficient. Obviously you have the ability to do more advanced tuning, but in most of the case, you can stick with just setting the heap size. So ZGC was initially introduced in JDK 11 as an experimental feature limited on Linux only. It has been improved. In JDK 14, we are adding support for macOS and Windows. We're adding support for tiny heaps and so on and so on. And finally, in September, in JDK 15, ZGC will be a production features. So that's something that you can use into production. This is a presentation. This is a picture that I took a few months ago when we were allowed to travel at JFocus. And this was a presentation done by Monica Beckwith from Microsoft. And she has these nice quotes. ZGC shines when it comes to responsiveness. So I highly encourage you to check her presentation, which is now online. So while we are on the ZGC front, while we are on the GC front, let's also talk about G1 GC, which is the default GC in the JDK. So it's not because we're doing investment in ZGC that we are not doing investment in G1. So for example, in 14, we have added NUMA support for G1. So NUMA stands for non-uniform memory access. So it basically means that the memory is not equidistant from every socket or core. So accessing memory from a given socket might be more expensive. It might induce more latency. Parallel GC was already NUMA aware since a long time. Now G1 is also NUMA aware. So since JDK 8, we have done over 700 enhancements in G1 across the board. And if you take all those enhancements together, not only they improve the throughput and the parallelism, but also they are reducing the footprint. So basically, they improve G1 across the board. So this is an example. So the chart at the bottom is an example of the extra overhead that it takes to deal with, in this case, 16 gigabyte heaps. So in JDK 8, at the top, you see that with G1, you basically need around another extra 4 gigabyte to deal with a 16 gigabyte heap. In 11, it was improved and reduced to 2.7 gigabyte. And in 14, you see that it has been decreased to around 1.7 extra 1.7 gigabyte heap. So, 1.7 extra memory needed to handle a 16 gigabyte heap. So basically, you can see that across the board we are improving G1 across the different release. Something important to keep in mind. These slides show the improvement that we have done in terms of latency. So from well, the thing that we saw here is that basically in 14, JDK 14, we have done some improvements regarding G1s. This slide is using the spec GBB. There are two versions of the results, so max GOPS and critical GOPS. Critical GOPS takes into account the latency, and we have increased the G1 performance in 14. There's a small drop-off if you look at on the right side, but when we see the improvement that we have done on the latency, it's okay to pay that small throughput drop-off. Something else that we have noticed is this, and you can see. So this was with a very specific use case. It was with a 16 gigabyte heap, and you can clearly see that in that case, G1 in GTK14 doesn't perform well, and it was basically due to a very specific bugs. How the region size were calculated. This has been fixed in 15, and you see that basically it has boosted the performance of G1. So given that we've gotten rid of that issue. So if you want to learn more about the improvement that we have done in G1 across the different releases, I encourage you to check the slide that is at the bottom of the slides. Now, something that we're also working on in every release is the startup time. So this slide shows the startup time from 8 to 11, and clearly smaller is better. So between 8 and 11, with a small basic Hello World application, we had a regression, and this has been fixed. Now you can see that between 13 and 14, we have reduced the startup time of a Java application. Now, given that we're reaching very low startup time, it's getting more and more difficult to improve that. But still, that's something that we are still working on. So we might expect some improvements on that front in 15 as well. These slides shows different use cases. So the first one is a Hello World application. The second one is a Hello World application using Lambda. And the third one, the yellow one, is a Hello World application that is using concat string. And again, across the board, we are working on improving the startup time of Java application. If you want to learn more, you should visit the links that is at the bottom of the slide. That's a colleague who is working on. That is the blogs of a colleague who is working specifically on performance in the Java platform. So let's talk about Project Valhalla. So since a long time, the Java platform has been improved to make sure that your code can run efficiently. So performance has always been a focus. Valhalla is basically about rebooting the way, rebooting the way the Java platform deal with data into memory. So it's really about optimizing how we can optimize data within the memory. And if you look at the Java type system, it's a very powerful things, but it misses some flexibility in some cases. And the main issue is that every object has an identity. Now, don't get me wrong. Object identity is something that we need in the platform. It enables mutability, it allows layered polymorphism, and so on and so on. Now, the thing is that there are some use cases where object identity is not needed. But still, when it's not needed, you have to pay for that price. So basically, Project Valhalla is about introducing new inline classes. So basically, classes that would be code like a class, but when they are stored into memory, they would work like a primitive types, like an int. Now, Project Valhalla is the huge effort. That's something that has been started, I think, 5 or 6 years ago. It has impact on the Java language because we need to add a new keywords to basically tell that, okay, this is an inline classes. It has impact on the JVM. It will also have impact on in the GC, in the JVMs. The compiler has also to be aware of that, and so on and so on. But the final goal of Project Valhalla is to enable a flatter and denser memory layout. Basically, avoid to have indirection when we want to access specific types. That's something that will be very important, especially with the new hardware that we have and the new memory that are given to us. Another ambitious project is Project Loom. So Project Loom is tackling a different aspect of the Java platform, and that's the concurrency. So since the beginning, Java supports threads. So when you write an application, most of the time your application has to compete for resources, including blocking resourcing, such as I/O. So we write multi-thread application, and well, it's expensive to block, for example, for waiting. So to block a thread waiting for some data to come from the network. So for example, so that's an example. So what we do, well, either we block. The issue is that that code will not scale and it will clearly underutilize the resources that we have. The other approach is that we can use some more reactive solutions. Now, the drawback of a reactive solution is that it's hard to code. And also that code is very hard to observe and hard to maintain. Now, writing a blocking code is very easy. The thing is that it will not scale. So Project Loom is basically about solving that, making concurrency simple again. How? Well, Project Loom will introduce lighter threads, called basically virtual threads. Virtual threads are threads that will be managed and scheduled by the Java virtual machines versus native threads that are managed by the underlying kernel of the operating systems. And the virtual threads, so are basically Java objects, Java construct. They are super lightweight. So you can afford to write blocking code with virtual thread because those threads are super cheap. They are so cheap that you don't want to pull them. I mean, pulling a virtual thread will add extra costs. So you don't pull virtual threads. So that's the main goal of Project Loom. Now, we have today early access builds, GDK builds that you can use to test with some Loom prototype and more specifically with virtual threads. But Loom is gradually impacting the platform. For example, in GDK 13, we have added JEP 353, which was about re-implementing the legacy socket API. That work was done to revamp the underlying socket API, but that's something that was done also in preparation of Loom. And in GDK 15, we'll have a JEP 373, which is about re-implementing the legacy datagram socket API. Again, that's something that we are doing not only to improve the platform, but also in preparation for virtual threads that will come later on. Another ambitious project is Project Panama. So Project Panama is about improving and enriching the connection between the Java virtual machine and some well-known foreign API. Today, we have GNI, Java Native Interface, but GNI is very cumbersome and difficult to use. Panama is basically about replacing GNI with an easier-to-use approach. In terms of deliverables, Panama is focusing on three aspects. The foreign memory access API, so basically how we can efficiently and securely access memory that is not on the heap. So basically native memory, memory handled outside of the JVM. And this is done through the foreign memory access API. That is an incubator in GDK 14. So JEP 370 is incubating the foreign memory access API. And there's a second incubator round in 15 with JEP 383. So foreign memory access API is one aspect of Panama. Another one is extraction, basically having some kind of tooling that we can use to easily extract headers and so basically extract from the native headers some and generate var and method Java handles. Now, the tooling is the tools that do that is very mechanics. So we also think about adding an API that basically you can use to customize that extraction process. And finally, another deliverable of Panama is the vector API. That's an API that you will use to express computation that will compile at runtime optimally on vector on hardware CPU that support vectorization, like Intel SSC, for example. Now, I've added this JEP, which is a part of GDK 14, that is non-volatile mapped byte buffers. It's a very specific JEP. So it's not part of Panama, but it makes sense given that it's very close to the hardware. And there's some discussion over time that maybe this should be tackled within Panama. But that's just for information bullet. That's an API that has been added in GDK 14. Now let's talk about Project Amber. So the goal of Project Amber is about right-sizing the language ceremony. We can see in this slide that Amber starting around in Java 10 with the local variable type inference. And since then, Amber has delivered new features to the platform in 11, in 12, in 13, 14, and 15. And you can also see that since Java 12, Amber is leveraging the preview features. So the idea is basically that we're adding in the platform a new features in a preview form. So that means that it's not permanent yet. We can still make change, and basically based on the feedback that we will receive, we might want to make some change. So let's have a quick look at Ember in action. So I'm going to switch to IntelliJ. So this is an IntelliJ. In the interest of time, I've created a project. So the thing is that you need to check is, no, sorry. Given that I'm going to use some of the preview features in 14, you need to make sure that the project language level is set to 14 preview and not to 14. And that's something that you also have to configure here. So we should use 14 preview and not 14. If we don't do that, we will not be able to use the preview features. So I'm going to quickly create a Java application. So this is my application, origination. Okay, so the first thing that the first features that I'm going to use is the switch, the new switch expression. So for that, I'm going to first we're going to quickly. Oops, sorry. We're going to quickly look at the switch statement. So this is a typical switch statement. Let me move that. Oops. Oh, sorry, there's an issue here. So where is my? Oops. So sorry, I have a little issue here. Yeah, sorry.
No worries, that's fine.
No, but the screen is so big in front of me that I've put here. Okay, so let me do the enim, and let me add this method, which is using the old switch statement. So right. So this is a switch statement. So basically, it gets a day from the enums, and based on the day, it will actually tell me how much character it has. So let's use it. So switch expression, and today it's Tuesday, right? So and let's output that. So it compiles. It's a bit slow with Doom and so on. It's super slow, in fact. Okay, and well, we see the result. So origination, and the result is weight. That's one of the issues we have with the switch is the fall through. So basically, it used these cases, but here I forgot to put a break. So it fall through to the next, until the next break, which is this one. So I can solve that by adding a break. Another issue that we have is, for example, we have to repeat multiple times the different levels. So it's a bit error prone to write code such as this. Something else is that we are using an enum. So we know exactly how many labels we should have. And well, guess what? 1, 2, 3, 4, 5, 6, 7 days. But still, we're implementing a default branch, which is kind of useless. So let's look now at the expression, the switch expression. And so this is the new switch expression. So we can already see that we can have multiple labels. So that's already something that helps to read and obviously write the code. A switch expression is an expression. So that means that it will return a value. So how we can return value? Well, simply by using this simple way of, so the minus brackets and then the value itself. So let's switch, that's to the switch expression, and let's run that code. Also, so it compiles. And in this case, it's 7. Something else that we can notice is that there is no breaks. So there's no fall through within the switch expression. So we don't have to specify a break. As soon as we hit a specific case, we are exceeding the switch. Something else that is quite powerful in the switch expression is that the switch expression is enforcing exhaustiveness. So for example, if I'm commenting that, well, you see that IntelliJ is complaining here, saying that the switch expression does not cover all possible input values. So that basically the compiler is able to infer that given that I'm doing a switch over 7 days and I haven't implemented all the 7 days, well, there's an issue. So my code will not compile. So what can I do to solve that? Well, I can either insert a default branch or I can create the missing switch branch. Something else that we can do, so you see that it's very simple to return value by using this simple annotation. We can also, and let's say that for a given case, we need to do some very complex calculation to compute that value. So let's say var L equal 6 plus 1, for example. There is a new keyword, which is the yield keyword that we can use to return, well, to do some works before we return the actual value. So all in all, you see that the switch expression is greatly simplifying the code with whenever we have switch. So moving on to the next feature, and that's a big one, that's a records. So records are basically immutable data carrier classes. So let me create a record. So record, so I'm going to create a record person. It has a last name component and a first name component. Sorry. And boom, that's all it takes to create a record. So now I can do, for example, so var speakers equal new record. Sorry, not new record, but a new person. It has a last name component, and it has a first name component. And now, well, for example, we can use, well, the toString methods. Well, no, let's simply do that. Let's run that. And you see that we have a default toString method that has been implemented for that record. So let's have a quick look at the sources. So Java -p, all right, it's inline. Gnation, it's not Java, it's Java P. So this is our record. So we can see that it has two final fields. That's the component field, so the last name and the first name. By default, it has a canonical constructor that we can override. It has a toString method, it has a hashcode method, it has a equals method, and it has two accessors method. There's no setters because a record is final, so it's immutable. So we cannot change the value of the components. Obviously, we have the ability to override that. And we can also use a short compact constructor that basically reduces the boilerplate code that we have to write. So I'm going to quickly switch to one last features of Amber because I'm running out of time, and that's text blocks. So let's take, for example, this XML code snippets. Let's go back here. Basically, text blocks are multi-line string literals that are using triple quotes as delimiters. So this is how we define a text blocks, and we can. So that basically means that here, oops, south. So if I run this, Well, this is, you can see that the indentation, even though I have a space here, is correctly handled by the text block. So there are some specific rules that are defined by the text blocks. Now, the thing that text blocks doesn't provide is expression interpolation, but still we can do something like this. So here, so I've replaced artifact ID by S, and then I can say, for example, that my artifact ID is GNation. If I run this, so text blocks are very convenient for whenever you have to use multi-line strings, or if you are using structural language such as SQL, HTML, JSON in your code. So you see here that the artifact ID has been switched to GNation. So let's go back to the slide. Something we haven't discussed is in pattern matching with instance of. So it's very easy. So in the past, when you had an object instance, you had to test what type it was. So in this example, we're testing if it's a string. If it's a string, we are creating a new string object whose type is string, and we cast obj to that new S object. Now we can do that more easily just by adding a binding variable in the instance of test line. So you see that at the end, after string, I specify a S binding variable. So that means that within the scopes, I can work with that S. And obviously that S object, the scope of that S object is limited. So I can't use it outside of that scope. So we've seen the records. So they provide the data carrier class, and basically we have to write less code ceremony. We don't have to rely on the ID to write those, or we don't have to rely on external library to do that. Something that is very convenient. And text blocks basically give us the ability to easily work with a multi-line string literal within our codes. And finally, the switch expression that we are discussed. So those are some of the features that are leaking through those large, ambitious projects. Clearly, today, Project Amber has delivered the most, but we can expect way more from Panama, Loom, Valhalla, and so on over time. ZGC is also nearly done, given that in GTK 15 it will be production. That doesn't mean that there are not smaller features that are not added to the platform. In 14, we have a helpful null pointer exception. So we have all seen that code where we have a null pointer exception, and we know where it happened, line 666. So we dive in line 666, and then we see something like that. Now, with the helpful null pointer exception, we just have to add these flags, and we'll get, whenever the null pointer exception is raised, we'll get more details that will help us to pinpoint exactly where that null pointer is raised. Something that is super convenient. You have to specifically enable that, so it's not something that is those days done by default, but that's a standard feature of starting from GDK 14. GDK file recorder is also something that is useful when it comes to observing a running application. So it's something that is available since Java 9. It was open source in 11. Basically the idea is that it's some kind of black box that is running alongside your application, and it emits events from the Java virtual machines up to event from your own Java code. In the past, to use GFR, basically the idea was you run the application, you record, you do a GFR recording, you dump that into disk, and then you do a post-mortem analysis of that GFR dump. In 14, we're adding a new event stream API that basically gives the ability to do a continuous consumption of GFR data live, both in process and out process. So that's something that basically allows you to monitor live your running application. You can do that into production, given that the GFR overhead is very, very low. So it's safe to use it in production. Now, we're also enhancing GFR itself. So through each features release, we are adding new event types. You can see that from 13 to 14, we have added only 2 event types, but from 14 to 15, we're adding 12 additional event types. So that's something else that we are improving over time through each features release. Something else that is part of 14 is GPackage. It's a tool that basically allows you to package Java application into native package. So for Windows, you will have an MSI or a .exe file. For Linux, you will get a deb file or an RPM package. So that's something that is still in incubation, but that's something that you can leverage starting GTK 14. Finally, GTK 15 will be released in September. I'm not going to spend a lot of time on this. This is the content as of this morning of GTK 15. We already discussed some of this, like ZGC, that will be a production features. Text block will be final in 15. I just want to quickly mention Hidden Class and SIL Class, which are part of 15. So Hidden Class is something that's going to be used by frameworks developers. It basically gives the ability from an application, Java application, to generate on the fly classes, and those classes cannot be used by other classes. Typically, that's something that frameworks do. And then we have SIL Class that basically solves the issue that we have with the class hierarchy. So basically, class hierarchy is something that is used to foster code reuse. So you have a superclass that can be inherited by many subclass. The problem is that we can also use class hierarchy to model different possibility within a given domain. Textographic applications, for example. So we have the notion of a shapes, and that shape is extended by a sub-shape, like a square, an hexagon, a circle, and so on. The problem is that Java assumes that code reuse is always the goal of the class hierarchy, and that's not the case. So SIL class are solving that issue. It allows a class or an interface to control which code, so which class or interface is responsible for implementing itself. And obviously, code reuse is still possible within that closed class hierarchy. How it works? We have a new SIL modifier and a new permit clause. So these are some examples using the shape classes. So you see that we have these class shapes. It's SILs. So that basically means that it needs to tell which subclasses can implement that shape classes. Circles, rectangle, and square can implement that shape classes. There are some tweaks that you can do based on the proximity of the code. So if it's within the same modules or the same package, you don't have to use the full package name. And finally, if all the classes, so the main classes and the subclasses are within the same files, the permit is inferred. So you don't have to specify permits. So in this case, again, the SIL class is SILed, and only circle, rectangle, and square can extend. Sorry, in this case, shape is SILed, and only circle, rectangle, and square can extend shapes. Now, you shouldn't confuse hidden class. Hidden class is something that you will likely not use. It's something that is used by mostly frameworks developers with SIL class. SIL class gives us the ability to define a restricted class hierarchy, and still, we obviously still have the ability to reuse code within that hierarchy. In the past, SIL class used to be called SIL types, so it's a bit confusing. And finally, we will have also inline classes, which in the past were called value types. And inline classes are basically one of the deliverables of Project Valhalla.
Hey, David, sorry, we had to wrap up.
Okay, wrap up.
Yeah, no, wonderful, actually.
So I just want to quickly mention another new project that we have quickly announced. That's Project Laden. So Laden is about bringing a native image into the Java platform. So think about GraalVM native image, but something Laden would provide that directly within the Java platform. So that's the content we have quickly discussed of GTK 14. It's available today. So give it a try and please use it. And I will just conclude by reiterating that Java is still free, that we have put in place everything to deliver faster, and that clearly we never have such a rich features pipeline. And with that, I'd like to thank you for your time.
Wonderful, David. Thank you so much for that great presentation. Well, we don't have any time to QA, but I would like to ask you a really quick question. I mean, probably it's going to be like a long answer. I don't know, but it's not. I mean, it's somehow related with what you mentioned first, which was, I mean, we Java was like 25 years, like a couple of weeks ago, right? And I'm guessing that a lot of people even didn't expect that Java will reach this amount of usage and this amount of popularity, right?
Yep.
So what are your feelings about the next 25 years for Java?
So I think this is just the beginning of Java. When you see the pipeline that we're working on, such as Project Valhalla, Loom, Java is a bright future. If you just need a short answer, Java is a very bright future.
Wonderful. Okay, David, I'm going to let you go. So thank you so much for joining us today. And thank you for the wonderful presentation. And stay safe. So we hope that we can hook up in some other conference when we get the travel ban off.
Yep.
And hopefully you can come to Portugal next year again.
Yep. See you. Bye-bye.
Okay, bye-bye.